So here are a couple examples. So this is the classic, what we call the Heaney Laser. And of course, do I have my Heaney Laser pointer here? No, I don't. So you have all seen and probably even used a Heaney Laser. That is the classic red laser pointer that we kind of see commonly, right, used. Okay, so those are created. So the laser cavity has a ratio of helium and neon. And the reason for that is, as it turns out, helium is really good at absorbing the pumping radiation. And a stopgap is created. So a population inversion is created from helium colliding with neighboring neons. And you notice the helium is way in excess. So it will inelastically collide with a neon and leave the neon in an elevated state. And there's a delay there, right? Because we're actually waiting for the molecules to diffuse around and collide. Okay? So that creates the population inversion in the helium neon laser. And then now you get actually several strong lines from the neon emission. So the most famous one, the 632 nanometer, right? That's our red Heaney laser that we're so used to seeing. And that actually comes from neon relaxing from the 2p5 5s1 down to the 2p5 3p1. This is your exam, what was that, 3 that I tortured you guys all with, right? And you can see there's no laser action that comes from that line. So the principal line that we get is from this upper level. Okay, so you can also get an infrared line, a 1.2 micrometer, or even a 3.4 micrometer, if the cavity were designed correctly. So we could totally get infrared laser frequencies out of our Heaney laser if the cavity were some resonant mode. So that's what we call these things. Yep, resonant mode. And resonant mode meaning some half integer wavelength of the laser action. Okay. So an argon ion laser is another popular or common laser. So this is created from about 1 torr of argon in a little resonating cavity. And an ion of argon is created via electric discharge. Okay. And so that's what creates the lag time, so that we're fully ionizing the argon plus. Okay. You can typically get a strong line, 554, 450 to 5. I can't talk. You can get a pretty typical strong line with a range depending on what, how much of the argon plus you've ionized. But the main argon line that you get is this 72 nanometer. So that's a vacuum ultraviolet laser.